Hello, and welcome to Chapter 8. We're going to take a walk through some of the problems and concepts of this chapter. This first question in your homework asks about the correct meaning of a p-value of 0.003. The answer is already selected here. A p-value of 0.003, or 3,000th, indicates that 3 out of every 1,000 random samples of the same size from the same population would produce the same result, or a result more unusual. The second question asks us to consider the probability of a type 1 error. A type 1 error is rejecting the null hypothesis when you should not have, and the probability of a type 1 error is directly equal to the significance level, so in this case, 0.05. The third question asks us about power. In this particular case, your null hypothesis is p equals 0.5. Your alternative hypothesis is p is less than 0.5. The power is found to be 95%. If we're using 40% for the value in the alternative hypothesis, the correct answer is C. If 40% really do attend church regularly, then the probability of rejecting a null hypothesis that this percentage is 50% for the alternative, that the percentage is less than 50% is 0.95. The power is the chance of correctly rejecting the null hypothesis, and the 40 is less than 50, therefore choice C. Okay, type 2 error. Should be able to compute this as well. A type 2 error, or a beta error, is the chance of not rejecting the null hypothesis when you should have. I'll let you take a look at that. Remember that you also have animations in this chapter that you can watch that might help you answer that question. Number 5, it says the researcher randomly sampled 20 students and found no evidence to reject the null hypothesis at the 5% level. What is true regarding the p-value? If you fail to reject HO, that means your p-value does not come out to be less than your significance level. So in this particular case, your p-value must be greater than 0.05. Determining the null hypothesis. The researcher hypothesized students got less than the recommended number of hours of sleep. That would be your alternative hypothesis. The null hypothesis is that mu equals 8. And we could check that. Continue. If you wanted to perform a one-sample t-test, which of the following is a correct statement? This is more of a conceptual question about understanding the idea of random sampling and doing a t-test. Problem number 8 is a test about proportions. You will begin by determining your null and alternative hypothesis and then proceed to use StatCrunch as demonstrated in the shorter video about the use of StatCrunch. If you're looking at this particular problem, keep in mind, as always, the null hypothesis must always have a statement about equality. That means you can immediately eliminate B, C, and F. We're testing the claim that under the same circumstances, 23% of them will be yellow, and so the alternative is that they are yellow or they're not yellow. So you would choose option A. To determine the test statistic, you would go directly to StatCrunch. Enter 137 yellow out of the total number of P's. Find the total number of P's by 429 plus 137. Then enter 0.05 for your level of significance, 23% for your confidence, for your hypotheses, and click compute. So let's go take a look at that. Stat, proportion, one sample with summary. So again, remember, you're going to be adding 429 plus 137 to get a total of 566. So you have 137 out of 566. The claim is that it's 23. And we're going to click compute. Now our p-value is given here, 0.4958. That's definitely not less than 0.05. So we would fail to reject HO, meaning the proportion is approximately 23%. Similar type of problem. Test the claim that is given, 501 out of 803. The majority means we're going to start off with 0.50 and then greater than 0.50 as our alternative. So we'd be choosing option B, and we would be running the same test that we just used in StatCrunch. Similar sort of problem, again, a proportion. Recall that always your null hypothesis always contains a statement about equality, and then your alternative is the claim for the problem. The next one asks us to find a range of values for the p-value for a two-tailed t-test with n is 17 and a test statistic of 2.275. So here's what we're going to do. We're going to go back to calculator like you did in chapter 6, for example. Instead of normal, we're going to choose t. N is 17, which means our degrees of freedom, which is always one less, would be 16. We're going to enter the t statistic, 2.275, into the box for the value and click compute. Now, we have a p-value given to us here. The chance or the probability of being beyond that point is 0.0185. So, a little bit less than 2. Now this is a two-tailed test, meaning that that 0.0185, or a little bit less than 2%, will also be at the bottom end. That would mean that the total for the p-value would be a little bit less than 5%, so we can pick the range and check our work. Use technology to find a p-value for a two-tailed test with n is 22 and a test statistic negative 1.536. Same idea. In this particular case, degrees of freedom is 21, less than negative 1.536. So in this particular case, our p-value is 0.0697 at one end. But remember that this is a two-tailed test, so you're going to double that value, and your p-value 0.1394. This next test is clearly explained on the shorter video about StatCrunch, but this one is testing the mean, and you can tell it's talking about the mean, and we're testing that the average must be no more than 210 seconds. Again, you're going to go through, choose your hypotheses, and then determine your critical values, your calculated t statistic, and so forth. This particular problem, you're going to use a t-test because all you have is the sample standard deviation. So make sure to choose the proper test in StatCrunch. Number 14, again, you're going to go through, choose your null and alternative hypotheses, but then notice you are not directly computing anything in StatCrunch. You are using the results in the top right-hand corner of the problem to answer the questions. Here, for example, is your calculated t, negative 2.03973. Here's your p-value or significance value, and then here's your x bar, s, and n. Use those to answer the question, enter the values. When it asks us to determine critical values, we would again go back to the t calculator. This particular problem is 0.05 level of significance, but it's a one-tailed test because we're only checking if the mean is less than 5.4. So I'm going to come back to the t calculator, use a degrees of freedom of 49, and set this so that I'm looking at the bottom of a distribution for the bottom 5%. So any t-value less than negative 1.67655 is what we will be testing. Okay, so this is not a two-tailed test. This is a one-tailed test. Again, how do I know that? Because I'm looking at the original claim where the mean is less than 5.4, it's a one-tailed test. So again, by the way, watch your decimal places here. So it says to round to 3 decimal places, negative 1.677. Null and alternative hypotheses. Again, read the question, answer very similar to the last one. Here's one where you're comparing filtered cigarettes to non-filtered cigarettes as a standard, and you are testing the claim that the mean part is less than 21.1 milligrams. So again, we're starting off with a null hypothesis where it's equal and an alternative where it's less. Then we're going to use a t-test to determine the values of the test statistic and the p-value for this problem. On number 17, you actually have raw data. You are testing the claim about a mean. So like the other problems, you're going to use a t-test, but in this particular case, I'm going to start this problem off here, we're going to click stat, p-stat, one sample with data, and select that column. The claim here is that it's 48, and the null is that it's 48, and the claim is that it's greater than 48. And we're going to use a 10% significance level. So when we compute, we're going to compare this to a 10% significance level. So in this particular case, of course, you would reject HO and assume HA. The mean is greater than 48. This particular question, if you read carefully, is asking us to determine if the standard deviation has decreased. So this is a problem where you would be using, again, a chi-squared, and we're determining whether the standard deviation has decreased. Number 21 is also a standard deviation problem. We're looking to see if it has a standard deviation different from the standard. When it says different from, or is there a difference between, it's an equal, not equals case. Okay. And again, remember when we go into StatCrunch for these type of problems, and you click Stat Variance Statistics, you're going to have to enter the sample variance. The sample variance, not the sample standard deviation. Although this says 0.22, you're going to enter 0.22 squared. Same with the hypothesis test. For the population standard deviation, we're not going to enter 0.35. We're going to enter 0.35 squared. So we're entering 0.1225 here. Be very careful to pay attention to that, or your answers will be very off. Number 20 asks us to watch a video and basically answer the question about being statistically significant. Number 21, similar question about p-values. Number 22 about null hypotheses. And number 23 about the video as well in finding statistically significant results. So again, keep in mind that we can find statistically significant results that are not meaningful in practical application. We can also find things that are not statistically significant even though we thought there might be a difference between our results. Be careful when you read these. Read the options very carefully. Sometimes all it takes is one word in here to change the answer. That's all for now, folks. Good luck. I hope you found that helpful for Chapter 8.